Hello, this is a Bullis Student Tutor, and today I'm going to be talking about linear congruences. So, linear congruences. This is essentially the analogous linear equation for modular arithmetic, and generally your equation will look like this, and you're going to want to solve for x, and so in this case, you're going to get a whole range of solutions. You're going to get x congruent to some number and some modulus, or you might not even have any solutions. So generally there's a pretty systematic way to go about solving these, but often you need some creativity in doing these sort of problems. So if you have this equation, ax plus b congruent to c modulus an integer m, the first step is usually just isolating ax. Usually you're going to start off by just subtracting b. Subtracting b like so. And so then you would generally go about dividing by a. Well, it's important to note that you can only be working with integers here. So if you can't find any number to divide by, something that divides both c minus b and a, you have to remember that when we're working in a modulus, we can always add to this side. You can always add some multiple n of m. And this will make more sense in an example. But anyway, the point is you want to keep adding numbers until you get something that allows you to divide by an integer that will both simplify a and whatever you have on your right hand side here. And so generally you have to be pretty creative with a problem like this, but you have to also remember that when you're dividing in modular arithmetic, you must divide your modulus by the GCD of the number which you divide everything by, as well as the modulus. So that may seem a little complicated, but it will make more sense in an example. Okay, so I'm going to work this first example. So first you want to isolate your 14x, and you'll get 35 modulo 21. And so immediately we see, okay, I can already divide. I can divide everything by 7. So if I divide everything by 7, I get 2x congruent to 5. And here, this is what I was talking about earlier. You can't just write mod 21. You have to divide by the GCD of the 7, which you just divided by, and 21. And so in that case, it would just be 7. So you have to divide your modulus by 7. You have to do 21 over 7, which is 3. So be careful of that. Okay, and so now you want to try and get a multiple of 2 on the right hand side. So let's just add 3. That's a multiple of 3. And what do you know? 8 modulo 3. So now the GCD of 2 and 3, well, 2 and 3 are relatively prime, so that won't be a problem. I can just divide by 2 and not worry about the modulus. So I'm going to have x congruent to 4, which I can subtract 3 is congruent to 1 modulo 3. And so those are going to describe all of my solutions to the above congruence relationship, that all I need is some x that is congruent to 1 modulo 3. Okay, so this last example I want to work out, it's an important one. So, it may look easy at first. You just add 7 to both sides, and you come up with 2x congruent to 13 modulo 12. Write that a little better. Modulo 12. And so what you need to notice here is that, okay, I can just add multiples of 12 to both sides, and eventually I'll get something that allows me to divide by 2, right? No, you can't. And the reason for this is, in order to divide something by 2, you need an even number. 13 is an odd number. Now all you can do is you can add even numbers to it. Multiples of 12 have to be even, because 12 is even. And if you add an odd with an even, you're always going to get an odd. So you're never going to get an even number on this right-hand side here. you're never going to be able to divide by 2. So what this means is that there are actually no solutions to the congruence. So I guess last time we had a solution modulo 3. This time we don't have any solution. So it's important to recognize that in some cases you will have no solutions. I think that was the last significant example I needed to go over. So this concludes the video on linear congruences, and this was brought to you by a Bullis Student Tutor. Thank you for watching.